Okay, welcome everybody to today's presentation. Again, we're going to be covering one of the topics that we showed you at the user group meeting this year, and we're going to look at a waveform press. And before we go into the introductory slides, let me just pop up the webcam here so you can see what we're going to work on. And today I'm going to create something that basically looks like this. This is a two-piece MDF press, as we can see the pieces there, and what this is designed to do is press a flat piece of Corian. So in actual fact, this flat blade was cut out first, then it's heated in a regular stove, would be put into the press pushes together, and that creates the wave shape that we can see there. Really, this is a proof of concept again, the idea being really just to show you some of the things that we need to think about in the software if we're going to create a press tool. One of the applications for this, just to show you that we kind of took it through, was this candle holder here. So you can see a whole selection of those blades in a candle holder. So I think that's enough of looking at me now. Let's go into the introductory slides here. So just going to run through and talk about the project before we go into Aspire itself. We're going to use Aspire 8.5 in today's demonstration. We're going to go through all the vector drawing for this example, the modeling and the toolpath creation. So as I just mentioned, we're going to create a tool using MDF that will allow us to bend heated Corian. Now, Corian is just a brand name for solid surface material. There are a number of other brands that you can get, but it's one of the more well-known ones. If you're not familiar with this product, then it's typically used for things like kitchen and bathroom countertops. What we're going to do is cut or design a part where we cut the blade shape first that we're going to preform. We're going to use 1/4 inch thick material, or in metric that would be around 6 millimeters. As I say, the press for this is going to be made from MDF, and I deliberately chose what you may well think of as quite a soft material for this, just to show that if the part is supported enough and if the material is malleable enough, then you can still form a relatively hard material like Corian with a relatively soft material like MDF, and you can see the form inside of a vise there. Some of the technical challenges for this, we need to think about alignment. So in this case, we're going to use these two dowels to help us align the two halves of our press and also help us keep the blade in the same place when it's being pressed together. The other thing we need to think about is material thickness. In this case, I'm going to do that when I'm drawing the vectors. So I'm going to create what will in effect be the center line of the wave in the Corian, and then we're going to offset this to allow for our 1/4 inch thickness. In this case, the physical challenges involved, at least in terms of this, are the forming force for the vise, although once Corian has been heated, then it is quite malleable. And material handling, so I use metal tongs for this. I'll show you some pictures in a minute of the exact process I used. And as I mentioned before, many possible applications. Here we're just showing you a simple example with this pre-cut blade form being bent into a wave, but obviously this could be used for many things, parts of furniture, lighting, all kinds of different applications for this. So in terms of what I actually did, I basically took my Corian blanks and heated them up in the stove. Later on I'm going to talk about a PDF document that you can download that DuPont actually publish online. DuPont is a manufacturer of Corian that explains things like the temperatures and how much time you need to leave things in the stove or a heater for. What I would say is make sure you've got a well ventilated area and really read up on this to make sure it's safe before you do it. Just because I survived this experience certainly doesn't mean I'd advocate everybody trying it. So read up on it and use appropriate safety equipment for it. There you can see me placing the part in the press, taking the press, putting the top half on, and then pressing that together between two other pieces of MDF in our portable vise. Typically, I left this for maybe 3 or 4 minutes, and at that point in time it had cooled enough so that it didn't want to deform anymore once I took it out. Certainly if you took it out immediately, it'd probably still be too warm and it would want to really go back to being flat again. And there you can see the part in the press before it was taken out and finished. Here's another few pictures just showing you the different pieces. In this case, what we're looking to do is make the two MDF parts and also to cut the 2D shape for our blade. There's a side view, and there's with the part just coming off the top. So in terms of the software side of this, what we're going to do is draw the blade shape, and I'm actually going to calculate a toolpath on one of those and use the vector selector and the levels to help us array that part and very quickly calculate the toolpaths on all the others. In a new session, we're going to copy the blade shape, and then we're going to draw the wave shape that we want that'll generate our split line, and we're going to use that in order to create two cross-section vectors that we can work within the two-rail sweep function in Aspire to create the shapes that you can see on the screen on the right. Finally, we're going to draw a selection of vector boundaries that will help us create our final toolpaths. We're going to do a bit of pocketing, going to machine out the dowel hole locations, and also, of course, we need to do the 3D roughing and finishing to give us our wave shape. So ultimately, we'll end up with something that looks like the part you can see in the top right there. So now I'm just going to go over to Aspire. As I said before, we're using Aspire 8.5 here. And we're going to do everything from scratch. We're going to start with the vectors and just work through the whole example all the way to the toolpaths. I'm going to create a new file here, and for these blades I want to make 8 of these, so I'm just going to lay out a part which is 16 inches by 8 inches, and then, as I mentioned before, our material thickness is 1/4 of an inch. Set the XY datum in the lower left corner and hit OK. For the blade, I'm going to draw half of it, and then I'm going to copy that over. And in order to help me get the size right, I'm going to start by drawing a rectangle that represents the size of our blade. So I'm going to put that at X0, Y0, the corner, and I'm going to make it 1.5 inches wide and 7 inches high, and hit create and close, and then we'll just select that and hit F9 on the keyboard, which is the shortcut key to center that in the middle of our job space. Next, as I say, I just want to draw half my blade so I can mirror it over. So I'm going to select this vector. I'm going to go into node editing by hitting N on the keyboard, right mouse click here, and just delete that span. I could also use D there as a shortcut. Now, because I want half, I'm just going to click on this node here, drag it across and snap to the midpoint. You can see the cursor changes to show me I'm snapping, and I can let go of that, and now I've got half my shape. Now we're still in node editing mode, so if I select this again, what I want to do is move this node down here, but I want to leave 3/4 of an inch at vertical at the bottom. If you remember, I was designing this blade so that it will go into our candle holder, and that means that I want a vertical piece at the bottom, 3/4 of an inch long, where I can put the dowel holes and also use that to insert in the candle holder so the dowel holes are hidden. Now I know this is 7 inches high, so if I right mouse click and go to properties, what I should be able to do with the node there is move it down. So I say I know it's 7 inches long, less 3/4 of an inch is going to be 6.25, and I want to go downwards, so we're going to make that a negative value and hit apply. So now this distance at the bottom should be 3/4 of an inch. If I wanted to just prove that, I could use the measure tool and just snap between those points there, and you can see over here it says the Y distance is 0.75. Now going to come back to our vector, go back into node editing, and over this span here I'm going to right mouse click and choose to convert that to a Bezier or a curve, and then I want to align these nodes. So the shortcut to do that, I'm going to select this node here, shift and select this node and hit X, and that will align their X coordinates. Do the same at the top, select this node, shift and select this node and hit Y to align their Y coordinates. And now I'm just going to select and use the arrow keys, the cursor keys on the keyboard, in order to jog the one at the side up and the one at the top over to the left. I like the way that that looks. Now, before I create the mirrored copy, we're going to draw our dowel hole. I'm going to click on draw circle. I know my dowels are 0.32 of an inch, and I'm just going to click and snap that into the corner there, and then let's go ahead and move that relative to its current position, 3/8 of an inch in X and 3/8 of an inch in Y, so we can see that there. In fact, in this case, 0.32 of an inch is probably a little bit large for these dowels, so I'd probably like to use a smaller dowel than that. So if we just take that object there and resize it, and we'll go down maybe to a 1/4 inch dowel. We don't want that to be too close to the edge. So that should still be in the right location. Again, if I wanted to just double check that and measure it, the center point there, so X distance 0.375, Y distance 0.375. Really, I knew that would be okay, but it's just good to show you that that hasn't moved. Now we've got half of our blade shape, so I can select the two vectors. I'm going to click on the icon to mirror them. Make sure flip about job center is checked and create a mirrored copy, and then just flip horizontal. Now I'm going to use the shortcut Control A on the keyboard to select all the vectors, hit J on the keyboard to go to the join command, and just hit the join option there, and what that'll do is join the endpoints of this one because they were pretty much coincident with each other. So now I've got the two dowel holes and one closed vector here. Now before I toolpath this, let's move it into position towards the edge of the part. So again, selecting the vectors, going to move the selected objects to an absolute position, in this case the lower left corner, and we're just going to set the X position there to be 0.5 of an inch and hit apply and close. Now I could go ahead and create all the array of the parts here, but what I want to do is toolpath this first, make sure the toolpath looks okay, put a tab in the place where I want it to be to hold the part when we cut it out, and then when I create the array and recalculate the toolpaths, it'll automatically pick up that information for me. To help me to do that recalculation, I'm actually going to move the two dowel holes onto a new layer, and we're just going to call that layer 2. So now I've got two layers here, layer 1 with the blade shape and layer 2 with the dowel holes, and you'll see how I'm going to use that in a moment when we calculate the toolpaths. So clicking on the icon to switch to the toolpaths tab, we're going to start by cutting the dowels. So I'm just going to first double check my material setup. Everything looks good there. So now we're going to machine these dowels, and I want to go just through into the spoil board. So I'm going to say Z plus 0.01 equals, so that's just going 0.01 of an inch through the material. I'm going to select a 3/16 inch end mill. I'm not going to worry too much about the speeds and feeds. You'd obviously need to make sure they were appropriate for your setup. I'm going to cut inside, and I'm going to create a bit of a negative allowance offset so that there's a space around these for the dowel. If the dowel's exactly 1/4 of an inch, which is the size we've drawn the circle, I want to slightly overcut the hole so it's a little bit bigger. I'm going to set this to do a spiral ramp. I like to do that when I'm cutting a small circular hole like this with the profiling, and we'll call this profile dowels. And now I'm going to use the vector selector button, and that's the software to select everything on layer 2. Remember, we just moved those dowel holes on there and hit calculate. Software will create the toolpath. We can preview that if we want. That's pretty straightforward. If I wanted to, I could use a solid preview in the 2D view to check that they're being overcut by the allowance. You can see that that's cutting slightly outside there. Now I'm going to create the cutout pass for the blade. So again, we're going to profile around, same depth, same tool. This time I'm going to cut on the outside, and what I want to do is add tabs on here. So let's set up some appropriate values, and I need to make sure the vector's selected using the vector selector. So I'm going to click on this, say layer 1, associate. You'll see why that's important in a minute. So now the vector's been chosen. Say edit tabs, and I'm just going to pop one sort of in the middle at the bottom there, and we'll call this profile cutout and calculate. And so if we preview that, we can see it being cut out and leaving the tab in the bottom there holding the part in place. Now once I'm happy with the way that's being machined, now we can array these, and I can very quickly recalculate the toolpaths because I use that layer association, and when I do the array it will keep these objects on the same layer. So let's hit F11 on the keyboard to go back to the design tab and into the 2D view, Control A to select all the vectors, click on the icon to create a linear array, and in this case what I want is 1 row in Y, 8 columns in X, a gap of 3/8 of an inch in X in between each one, and I'm going to flip every other one upside down just to get those to sit nicely together. So let's hit copy, There's all the sets we need, and because of using the vector selector and the layer association, I can just come across, click on the icon to recalculate all the toolpaths, and when I do that, the software will look at the rules that I set for each of these and pick the vectors accordingly. Because I told it for the dowels to pick closed vectors on layer 2, it picks all those up, and because I told it for the cutout to pick closed vectors on layer 1, it picks all of those up. So this is a reason why you may want to use the layers in the software and that vector selector. It's a very powerful feature that we have available to us. Now if we want to just double check these look okay, we can go into the preview, reset and preview all the toolpaths. There's the dowels, there's my blades being cut, and so at that stage I could go off and machine this and know that I've got all my blades machined. What I want to do now is take a copy of one of these blade vectors though, so we can go into another session of Aspire and we can actually create the model for our wave shape. So in this case I would save this file. I'm not going to bother here, you can just assume I've gone to File, Save As, but I'm going to take a copy of the vectors, right mouse click and copy that onto the clipboard, and I'm going to go into a new session. I'm not going to bother saving this, I already have it saved, and for our wave press I'm going to set up a job which is 10 inches here wide, 6 inches high, and we're going to use 3/4 inch MDF to cut these out of and hit OK. Going to right mouse click and paste that in, and I'm just going to center that using F9, and then I'm going to use the shortcut key 0, which will rotate that 45 degrees to the right, and 0 again to create 45 degrees to the right again, and then we'll just recenter that in the middle of the job there. So this is my blade. I know that my Corian blank is going to be cut to this shape, and now we can use this to help us to construct the other vectors we need. The first vector I want to create is going to be edited in a moment to give us our wave shape that we're going to then use with the modeling tools to create the 3D form. Now again, I'm going to draw a polyline. I'm going to snap to the center point here, but if you remember, I want this 3/4 inch of flat across, so I'm actually going to enter up here an angle of 0 and a length of 3/4 and hit add. So I know the first part of my line there is a horizontal part 3/4 inch long, and then I'm just going to snap this to the end. Now I'm going to extend this out a little because I would like my 3D surface to come slightly past the edges so that we can machine it easily with the tool going past the edges of the part here. So I'm going to click and draw a line, snap to the point here and just come out 0.3 inch. I can see that snapping there. Right mouse click, and with that selected, that little vector selected, I'm going to use Control, Shift and H on the keyboard to create a horizontal copy across the other side here. Now I want to take these vectors and join them together, but by constructing them in that way, if I go into node editing now, you can see where I've got these points. I've got these points here that coincide with the edges. I've got my 3/4 inch here, and what I want to do now in the node editing is add in some additional points that we're going to edit to give us our wave shape. So I'm just going to drag while in the node editing to select the midpoint, right mouse click on it and say insert a point. Do the same now with this new midpoint here and insert a point, and do the same with this one, right mouse click and insert a point. So we've effectively divided the line from here to here into 4 pieces. Now I'm going to select all the nodes except the end nodes and hit S on the keyboard to smooth them. So now all of these have the potential to be curves. I'm going to click on this one here. I'm going to right mouse click, so just to show you that there, we're in node editing mode. When I click on that blue node, it also selects its control handles, so I can right mouse click, go to the properties, and I'm going to set this to be negative 0.25 inch and hit apply. Then I'm going to do the same with this one, except this time with the properties I'm going to set it to be positive 0.1875 and apply, and with this one I'm going to select it and set the properties to be minus 0.125. So each of those has got slightly less distance, so we've just got a larger wave then tapering out towards the end here. So this represents the middle of my piece of Corian. What I need to do now is create an offset on this so that we've got some distance that the material would fit into. So I know my material is 1/4 inch thick, so we're going to need to offset this so there's 1/4 inch gap. Now before we do that, I'm just going to do a bit of layer management. I'm going to take my two dowel holes, I'm going to move those onto layer 1. Layer 2 has been selected here, so that's been our current layer, so I'm going to change this and we'll call this layer 1 blade, and I'm going to call layer 2 wave. I'm just going to switch off the blade layer for the moment, and then I'm going to draw a polyline, just snap to the end here and come out another 0.7 of an inch, and right mouse click to accept that. With that selected, I'm going to go to Control Shift and H again to create a copy across the other side, and you'll see how I'm going to use those two pieces in a moment. Now what I want to do is this offset command. Now if we imagine this is the middle, to create a 1/4 inch space, I want to offset it effectively up 1/8 of an inch and down 1/8 of an inch. So with that vector selected, I'm going to click on Offset Selected Vectors. I'm going to go in both directions by 1/8 of an inch, and I'm going to say delete the original. So if we hit offset there, you can see now I've got a space of 1/4 of an inch in between there, and you'll see how we're going to use this in a moment to create the two sides of our press. Now what I want to do is just close up some of the vectors here, so I'm going to select these two at the ends and copy them to the clipboard. Then I'm going to select these two and join them with a straight line, add this one at the end and join that with a straight line, then right mouse click and paste in a copy and do the same with this top one. So just taking the two end pieces and joining them with a straight line. Next I want to draw a block that represents our piece of MDF, so I'm going to draw a rectangle. I'm going to make this 9 inches wide and 0.75 inches high. Hit create, close, select that, and then F9 in order to center that on the part. Again, I'm just going to right mouse click and copy that to the clipboard, select these two vectors here, and now I'm just going to hold shift and move those down. Then right mouse click and paste in the copy of that vector there, and now you can see effectively what I've got is what's representing the thickness of our MDF and showing me at the moment where the part is going to sit within that. Now the two halves of the press as we've drawn them here, this is the bottom, this is the top. What I want to do is take these two vectors here and just flip those over so that they're facing the right way up. So I'm going to hit V on the keyboard to mirror those vertically. Now you can see that I don't have much space underneath my wave where the block is positioned at the moment, so I'm actually going to take both of these blocks and I'm going to move them down negative 0.1875 and hit apply and close. So now you can see if I use these as cross sections, I will have some material underneath my waves. Now in order to use them as cross sections, I'm going to need to trim away this top piece and open up the bottom. So we'll go over to the scissor tool, the interactive vector trim, and just click to trim the top pieces here, and then I'm just going to select this, go into node editing mode, and as we did earlier I'm just going to delete the span across the bottom of both of these. And so now what we've created are two open vectors that we can use as cross sections when we do our two rail swept shapes. So I'm just going to zoom out here and I'm just going to move both of these off the bottom of the job so they're out the way. Let's just scroll down, select this other one and just move that below there. Let's hit F to fit so we can see everything in the 2D view. And now we're ready to start constructing a few more of the vectors we're going to need before we do the modelling. So I'm going to switch back on the blade shape here and I'm going to create the vectors that are going to represent our drive rails for the two rail sweep. So I'm going to snap them to the end here and go up 2.5 inches and click and right mouse click to accept that. I'm going to use Control Shift and H to make a horizontal mirrored copy around the center of the job. Select both of these and hit F9 on the keyboard to center them in the middle of the part. Next I'm going to draw a rectangle that represents the outside of our press. So this is going to be our cutout shape eventually. I'm going to make that 8.5 by 2 and create, close, and just center that in the middle of the job as well. So I need to make sure, this is why we've got these lines a bit longer here, that our 3D shape is easily bigger than this, so that when we've done our toolpath in, we come back to cut this out, we're going to get a nice clean sharp vertical edges. Now I need two halves. I need a bottom and a top for the press, so I'm just going to select these vectors and move them to an absolute position with the lower left node selected there, down to the bottom of the part. So we'll set this up to be 0.375, hit apply and close, and then with those vectors still selected, I'm going to use Control Shift and this time V to create a vertical mirrored copy of those vectors. So quite a lot of vector work we're doing here. I'm using a lot of shortcut keys to make sure we can go through this as fluently as possible, and hopefully you're seeing the value really of learning those shortcut keys. So now we're ready to do our modeling for the two parts, and then we'll just need a few more vectors before we can go over and calculate the toolpaths. So from a modeling point of view, it's very, very simple. I'm just going to tile the windows so we can see the 2D view on the left and the 3D view on the right, and go into the modeling tab, click on the icon for the 2-rail sweep. For the bottom one, I'm going to select this vector, shift and select this vector, and so use that selection as the drive rails. They're both flowing in the same direction, so that's good. Then we can go into here and just select this profile as our bottom cross section, and we'll call this wave bottom and hit apply. I want to make sure that scale cross section with width is unchecked because we've drawn this vector to be the exact size that we need. That looks good. Now we can say start new component. I can select this vector, shift and select this vector, use selection, and this time I want to select the top of the two cross sections, and we'll call that wave top and hit apply and close that. Now hopefully you can see here a resemblance to the two pieces that I showed you early on in the demonstration, the two pieces that we're going to cut from the MDF, and you can imagine, having done the offsetting and with the space that we've got here, that we have a place for the Corian to sit. Just to remind you of that, let's go back to the slide here and you can see that there. So here you can see, hopefully we've got these shapes that resemble the waves that we've modelled, and here you can see how the Corian fits into that and the space we created with our vector offset. So at this stage we're ready to create the toolpaths. We need to create boundaries that are going to allow us to pocket the ends. We need to make sure we've got the circles in our toolpath selection vectors, and also a boundary for the 3D toolpath as well. So back into Aspire. What I'm going to do at this stage is select these two grayscales, and we'll just move those onto the blade layer so that we can see all the vectors through it. All I've done there is make sure they're on the very top layer that we've got, so all the other vectors will be displayed on top of those grayscales. Now within the drawing tab, I'm going to create a new layer here, and we'll call this toolpath vectors, and I'm going to make that orange so they're a little clearer for us to see once we've either created or moved a vector onto that layer. Now I said I want to pocket the ends to create the flat shapes here, so I'm going to select the rectangle tool, and I'm just going to click at the top and drag down to the bottom and let go, and then put in a width of 1. So there's our rectangular vector. Now we need to create several mirrored copies of that, again with the shortcut key. Going to use Control Shift and H to make a horizontal copy, reselect that holding the Shift key, Control Shift and V to make a vertical copy. As I mentioned, what I want to do is also take these holes and these cutout shapes and move or copy them onto that toolpath vectors layer. So there's the orange versions of those. And lastly, I need to create a vector for our 3D toolpath, and what this should be is slightly larger than my blade and also come past the edge of the part here. So what I'm going to do is draw a rectangle. I'm going to snap to the intersection points here and here, right mouse click to accept that, and with it still selected, I'm going to offset that outwards by 0.15 of an inch and say delete the original and select new and hit offset and close. So that's just given us that extra distance for the tool to go past the edge here to make sure that we're going to have space to fit our blank. Next, and say Control Shift and V to make a vertical copy of that, and now we should be able to switch off the other two layers here and just leave ourselves with the toolpath vectors. Now I'm going to click to go over to the toolpaths tab, and we'll just work our way through to calculate these. So first I'm going to check my material setup And in this case, because I've accurately sized these vectors when I created my models, I want to make sure that my models are pushed all the way down to the bottom of the block. So they're going to be the right size when we machine them. Everything else looks okay, so we'll just click the button there, and now we're ready to do our 3D machining. So I'm going to select these offset vectors for the boundaries for the 3D machining. We're going to start with the roughing. I'm going to use a ball nose 1/4 inch tool. Let's check the parameters for this, and we'll just set this so that we've got a fairly aggressive step over. Not going to worry about the speeds and feeds in this case. I am going to use the selected vector as the machine limit boundary. I don't need the boundary vector offset because I have already offset this vector, and we're going to put a machining allowance of 0.03, and we're going to 3D raster this. I think this will give me more of a kind of semi-finished look, which I prefer when using a large tool like this with this shape. So there's our toolpaths. If we change the material here, so let's change this to represent MDF and preview that so we can see what the roughing is going to do. It's going to do it on a couple of levels to machine that out. And I can always adjust that if I want. Now we can see it's taking a little bit of time to show me the preview here, so I may want to adjust my preview settings. We'll just wait a moment and let this finish before we look at doing that. So yeah, one of the new features in the software is this ability to adjust your preview settings. So under toolpaths, preview simulation quality, maybe we want to just knock this down to very high there, and now we can preview that, and you can see it'll rattle through a little bit quicker, which will certainly help us when we come to the finish machining. So the roughing looks good. For the finish machining, we're just going to come in using the same boundaries here and go to the finishing, and I'm actually going to use the same tool. There's no detail in this part, so I can use the 1/4 inch ball nose tool, and again we'll just put this down to 10% step over in this case, and everything else can remain the same. And because there's no small detail to get, then this should give us a nice clean finish over these wave shapes. So if we preview that, we can see that that's going to just take off the excess material we left with the allowance and also give us this nice clean finish. Now because these both use a 1/4 inch ball nose tool, we could output them as a single toolpath. So it may even be that you may be able to cut this with a finish without roughing. It just depends on kind of the consistency of your MDF and maybe the rigidity of your machine. There's certainly some machines would have no problem going straight to a finish on that, even though it's a relatively deep cut. So that's the 3D done. Next we want to pocket the ends. Now if I hover over these in the 3D view, at the bottom of the screen, and I'll just show you that area with the cursor here, that'll show me the X, Y, Z position of that value. Hopefully you can see that on the screen, and that's showing me a value of negative 0.1875 of an inch. So I'm going to select these end vectors. I'm going to go to pocket. I'm going to say we want to go 1875, 1/4 inch end mill, and just going to calculate that, and we'll preview that and see how that looks. Next we're going to go to the dowels. Now for this bottom set of dowels, I want that to hold the dowel in place, so we're just going to cut those almost to size. So I'm going to profile this. I'm going to go down to a depth of 0.5 with a 1875 tool, cut on the inside, and we're going to ramp that in. So we'll call that profile dowel O-5, calculate and preview, and there's no allowance on that because I want that to be a snug fit for the dowels. Then we'll duplicate that, double click on it, select these two at the top. In this case I want to add an allowance because I need this top one to be able to just slide on and off as we press the part and then want to release it. So we'll call that profile dowel through. So I also want to make sure it's going to cut all the way through the material, so in this case we'll set that to 0.76 of an inch, hit calculate and preview that. So that's going to slightly overcut that size, so that should be able to slide over and onto these dowels and then off again without wanting to pull them out of the bottom piece. Finally we're going to do our cutout pass using these vectors. Profile around, again going 0.76 of an inch through, round the outside. If we want to add tabs we can, So maybe if we didn't have a vacuum hold down or double-sided tape and we wanted to use the tabs to hold the part in place, we can just click them on here and calculate that and hit preview, and we'll see that machine through. We can maximize the 3D view now, and there you can see the two sides of our MDF press. So just to reiterate some of the things we've looked at here, we talked at the beginning about what we were looking to do was use relatively soft material to create something that could press hard material. We're going to make that material able to be pressed by heating it first, and there is some information that you can find on the web for that. If you look at the Vectric forum, forum.vectric.com, under the user group videos topic, the live stream videos topic, I have posted the link to the PDF document that will tell you about the technical information about heating and bending Corian. Within our example here, we started by drawing our blank, the blade shape. We used the array tool and the association with the layers in order to help us toolpath that. Then we took a copy of the blade across into Aspire, into another session of Aspire, and we built all our vectors we needed from that, offsetting them to create the space for the material thickness, then using the 2-rail sweep to form the 3D waves, and finally calculating the toolpaths that give us the part that you can see here. So that concludes this example. If you came late to this, then it will be posted on our YouTube channel in the almost immediate future afterwards. Normally within 5 to 10 minutes it will appear. If you have any questions, you're welcome to type them into the chat now. But I will stop the stream. We'll just use the chat there for a moment to answer those. Otherwise, you can always post questions on the Vectric forum. There will be other videos scheduled. We have another one tomorrow at 4 o'clock where we look at a tool to form a bowl shape out of Corian, which is quite an interesting example. And then we will be notifying you next week about other scheduled demos for the rest of the user group before eventually all the videos and files will be posted on our website. So thank you very much for watching. If you have questions now, please post them in the chat, but I will stop the stream and we'll just use the text to answer them.